Alright class, this is the last day of notes for Unit 3, and it's basically taking our rational expressions and turning them into equations and solving them. Okay, but the process is very similar to the second method for solving complex fractions. You're going to multiply the whole equation by the LCD to cancel out the fractions and then solve. Or a shortcut, if you just have a fraction equal to a fraction with no plus or minus other fractions, you can cross multiply. So we'll do both methods today. So here's what we're going to do. You first want to know what are the domain restrictions, then figure out what the LCD is, then multiply by the LCD, solve, and check your answer against the domain. So example 1. First thing I note that the domain is that x cannot equal, and if you look at the bottom, the only thing that would make the bottom 0 is if x is 0. So x cannot be 0 for this problem. Okay. The LCD, things that will cancel out my denominator, would be I need an x and a 2. So I'm going to multiply everything by 2 and x. So that's the first step. I multiply the whole thing by 2x. So I get 3 times 2x over x minus 2x over 2 equals 12 times 2x over x. Again, the reason why we did that is now that these go away. So we're left with a 6 minus these go away, x equals these go away, 24. Okay, move that over, you get negative x is equal to positive 18, or x is equal to negative 18. Last step, check to make sure that that can exist. Negative 18 is not a problem because the only thing that we could not get was 0. So negative 18 is a solution, and we put it in set notation. And that's how you do these. LCD. First state the domain though. So for number 2, put it right above it, the domain. The only thing that would make the bottom 0 here is that x cannot equal negative 1. So that's that. And our LCD happens to be x plus 1. So I'm going to multiply this whole equation by just x plus 1 on the top. And I get 5x times x plus 1 over x plus 1. So those will cancel. Equals 4 times x plus 1. That will not cancel. Minus 5 times x plus 1 over x plus 1. So now I can cancel out my x plus 1s. And I'm left with the equation 5x is equal to, this you want to distribute so you can solve it, 4x plus 4 minus just 5. I'm going to move this over. You get x is equal to 4 minus 5, which is negative 1. So that's what you get. However, again, when you get an answer, you check your domain. Uh-oh, we have a problem. We can't have negative 1. So that means that this is not a solution. And since we didn't get any other solutions, our final answer is that there are no solutions. We got an extraneous solution, though, of negative 1. Okay? Alright, so that's what happens when it's in the domain, or it's a restriction. So you have to be careful with that. Remember to factor to see what your LCD is, and also to see your domain restriction. So the bottom of this fraction is x plus 2x minus 2. So that means that the domain is that x cannot equal plus or minus 2, and our LCD is x plus 2x minus 2. As you get better at this, you don't have to show that big step. You can just show what's left. So for example, when I multiply this chunk to this chunk, the x minus 2's are going to be canceled, so we're going to be left with a 3x minus 2, and which of these pieces are left? An x plus 2. Equals 6, and then over both of those things, so we're just left with a 6 plus 1 times both of these. Okay, so now we FOIL and solve. 3x squared minus 2 plus 6 is a plus 4x minus 4 equals 6 plus, and when you FOIL that, they're conjugates, you should know that's the x squared minus 4. Move the x squared over and move the 6 minus 4, which is positive 2. So subtract 2 over and subtract an x squared over. You get a 2x squared plus 4x minus 6 equals 0. So there are two solutions for this. Factor out a 2. Factor the quadratic. So what do we have? 3 and 1 plus 3 minus 1. The 2 doesn't really matter at this stage. Zero product property. So we get x equals negative 3 and x equals 1. Look at your domain. We can have both those numbers. So my two solutions are 3 or negative 3 and 1, both in the solution set. Okay? Alright, so the last two we're going to do cross multiplying. But again, before you do that, you have to factor it and look at the domain. So the domain for number 4 is that x cannot be 0 or negative 4. And then to cross multiply, if you don't remember how to do that, you take these pieces and multiply them and set it equal to these pieces multiplied together. So we get x squared plus 4x, because it's times 1, equals 3 times x plus 4. So let's solve this equation. Make sure you distribute the 3. You get x squared plus 1x minus 12 equals 0. We factor. That's a 3 and a 4 plus 4 and minus 3. Zero product property. You get negative 4 and 3. Again, go back to your domain restrictions. Uh-oh, we can't have negative 4. So that means that my only solution here in the brackets is 3, and that we got an extraneous solution, because it can't exist, of negative 4. And that's it. One more. Again, factor. Because that helps you with your domain restrictions. So our domain for this problem is that x cannot equal negative 4 or negative 8, just by looking at these two pieces, setting them equal to 0. Now, because we have just a fraction equal to a fraction, we can cross multiply, so these two multiply together. I'm going to leave it in unfactored form for that part, because multiplying, you can do that. So we have two FOILings. 2x squared, 12 plus 16 is a 28x. 6 times 16 is a 96. 3x squared plus 12 plus 30 is plus 42x. 12 times 10 is plus 120. Alright, I'm going to move everything to the right. So 0 is equal to 3 minus 2 is an x squared. 42 minus 28 is a positive 14x. And 120 minus 96 is 24. So we get this polynomial. Two numbers that multiply to 24, 12 and 2. So we get x plus 2 equals 0 and x plus 12 equals 0. X equals negative 2, x equals negative 12. Okay? Those are both okay based on our domain restrictions, so therefore they both go into the bracket. Okay? So with solving, you're trying to get rid of the fractions and then just solving an equation. Either it's a quadratic or it's a linear. And that is all you have to worry about. Just remember to get the domain first and factor to do that. And then look at your answer compared to the domain restriction to make sure that it is okay to have. Okay, and that is it.